Alright, here I have a Mr.Buddy heater. Right, right now it's on high. As you see, it's on high. What I wanted to show you guys was this little stove fan that I put on here. I used two 8-frame metal clamps. Make sure it's metal because it gets hot. Use anything else, it'll melt. Use plastic, it'll melt. And you don't touch this with your bare hands. If you touch these with your bare hands, you'll burn. Right now, like I said, I had it on high. It's probably been on high for about 5 minutes now, and prior to that, it's been on low for about half an hour. So I'm actually gonna use a little thermometer here. Have it set on Fahrenheit. Let me switch it to Celsius because the manual on this thing said the operating temperature for this fan is between 50 degrees Celsius and I think it was 200 degrees Celsius. So was it 200? No, excuse me, 300 degrees Celsius in the manual, the owner's manual. So I'm gonna shoot this thing at the base of that. You see the laser there? The laser is showing at the base. So it's kind of steady around 230 or so, 230-ish Celsius. So in Fahrenheit, that's 450. Right, around 450 or so. So it's been pretty steady. I don't think you want to go up much more than that. I forgot what temperature it was where this fan will actually, it has a little built-in safety mechanism where if it gets too hot, it will actually tilt, and when it tilts, there's less physical contact between the top half and the bottom half, and it will actually cool it down so it doesn't overheat what do they call it, the tank motor or tank motor. Basically it produces electricity by heat conductivity versus any moving parts. So yeah, so these little A clamps are really hot as well. Let me show you how hot that is, because this A clamps are they're shiny, so these thermometers don't work very well when you point them at shiny metal. It doesn't read accurately. So let me show you. Let's see. Let me at the base of the handle right there. Let's see. Point right here. So it's 136. Actually hotter than that, I think. This side 130 something. But let me point it into where the spring is. The spring of the clamp, because that one's black. You guys see how hot it actually is. So it's actually 360 Fahrenheit, right? 365 Fahrenheit. What's that in Celsius? 185. So that's hot. That's way above boiling temperature, right? Of water. Water only boils at 212 Fahrenheit or 100 Celsius. So that tells me it's very hot. So this is at the end of the spring, the very tip of the spring here. It still looks like it's still, I keep my hand steady, but it's still somewhere close to the boiling temperature. Let's go back to this base here, see if it gained any heat. Oh yeah, it did gain some heat. It's at 460 460-ish. So that's Celsius is what, 236. So still 70, 65, 60 degrees below its operating temperature or so. But anyways, and putting my hand over here, I could feel the heat blowing back. The reason why I have it blowing back instead of blowing forward, normally I would rather have it blow forward because heat naturally rises. So since this thing is, if you look at it, it's actually pointing, the fan's pointing up. If I flip this around the other way, it will be pointing down. That's probably what you want. You want pointed down, so that way the heat is at a lower level, and that way wherever you're heating, it will be the temperature would be more even at the from at lower level and higher level. If you have it pointing up, it brings the heat more up. And if I didn't have this fan at all, most of the heat would just rise straight up. So that's even less efficient. So the reason why I have it pointed back is because you know, this is the bathroom in here, and this is the only really safe place I could put it, because you know, over on this side it's, you know, it's this fake, you know, it's this fake wood, fake hardwood, and the heat on here will actually cause this to distort, and I actually have a spot where it's slightly distorted. If you don't look at it, you wouldn't notice, but if you actually pay attention and if you actually put your feet around it and rub it, you actually feel where the joints are, where the connection points are. You can feel it a little bit slightly off. So I put it here where the tile is, and it seemed to be okay. And you know, putting my feet over here, I can feel the heat here. It's not real hot, but it's warm, very warm. Yeah, very warm. So anyways, so I've been talking for like over 5 minutes now. Let's look at this thing. So it's pretty stable. Right? It seems to be pretty stable to me. Right? 240 something. 460. So yeah, it's pretty stable. So I'm actually gonna leave it at low because it's so efficient with the fan. It's actually more efficient with the fan. And at low, and I had, like I said earlier in the video, at low I actually had it left at for like half an hour already, running for half an hour, and it was reading in Celsius. It was reading, I think it was, if I remember, it was reading 170, about 170 degrees Celsius. So look at that, it's dropping pretty fast. Earlier it was what, 260 or something like that, or 240. What was it? Yeah, 240. So at 240 or 480 or something like that, but it's dropping pretty quickly. So remember, this whole thing here is made of aluminum. So aluminum conducts heat very fast. It's used as a heat sink. So anyways, leaving it low, it still spins pretty well, and I can still feel the. I didn't feel much of a difference between, because that electricity is generated by the heat. The more heat, it should spin a little faster, but it's not that much of a difference in speed, I don't think. This fan makes it very efficient, and it's completely quiet. You hear that? That's actually the flame, the pilot. That's actually the pilot, or actually the ceramic, the bottom left corner on the ceramic piece right there. So that's where that noise is coming from. Otherwise, the fan itself is like pretty much silent. I could barely hear like a little electrical buzz, just barely. I mean, I'm only like about 18. My ears are only about 18 inches away. So yeah, still pretty cool. Let's see. Let's look at this again. See, it's dropping again. 193. Eventually, it's gonna drop to about 170 or so degrees. But anyways. Yeah, so this is better. Now I've seen people that have the setting set up, but instead of using A clamps, they actually cut into the it's hot. They cut into the base right here, along the base, along where the edge right here is. They actually like take a hacksaw and cut into that. I think that's a bad idea. You want as much heat transfer, because when you cut into that, you have less heat transfer into up the motor. So you actually lose energy there like that. So this one, that way that's full heat transfer, so you don't lose as much energy. So you could run it at a lower heat on the heater, and still have a really good flow on the fan. Yeah, this is easier. No work. You just get some A clamps, and these things are cheap, and they're only a couple bucks. Make sure it's all metal. Don't get any plastic. If yours has like some type of plastic handle or rubber handle, take it off. These ones had those rubber handles that covered the handles, but also the jaw. It had some rubber pieces. I actually took them all off, and whatever glue was here, I actually scraped it off with a utility knife, because I knew it was gonna it's gonna be really hot, and that's whatever glue or rubber that's there, or plastics that's there, it's gonna melt and burn, and that stuff is gonna be nasty. Okay. Let's see. Let's look at it again, temperature wise. So there, it's dropping to 180 something now. So again, before I had set it to high. It was on low for half an hour, and it stayed at about 170 or so, 169, 170. Let's look at the clamp there. The clamp's probably cooler as well. Earlier it was what? It was pretty hot. So look at that. It's cooled a lot. 126C, so that's Celsius is 2 something. Earlier it was like 3 something, right? 3 something Fahrenheit. So that's high. 3 something Fahrenheit is very high. But now it's only 2 something Fahrenheit. It's actually I think it's gonna drop even lower than that. I think it's gonna drop, once the temperature stabilizes. I believe this is gonna drop down to about 230, if I can remember right, before I turn it up to high. So yeah, and the fan's still blowing. So that's the Mr.Buddy heater with a little stove fan. And this one I got is actually the brand right here. It's Tap Life. That's from Amazon. I forgot how much it was. It wasn't that expensive. It was shoot, I just bought it like a week or so ago, and I just got it today. I can't remember how much it was now. But anyways, so they have different brands. I was looking at them, and the things that I was looking at is I want to make sure that they had that adjustable tilt, so that way it could save itself, so it doesn't overheat the tech motor. Other thing I wanted to look at was the diameter of the fan itself. I want a larger diameter, so it could hopefully the larger diameter will move more air as well. But it also depends on the fan design, the fan blade. If you have a bad fan blade design, it doesn't work very well. It might not move any air at all if it's a bad design. Other thing about this thing, why I got this. Let's see if I can slow this thing down. So you look at the fan blade right there. You see on the center here, it has those ridges. That's there to reinforce the blade so that it doesn't warp as easily. And this one obviously is a four blade fan. Four blade fan. I think if I got like I wouldn't get a 2-blade fan. I don't think 2-blade would be very efficient. 4-blade or even a 3-blade or even a 5-blade might be okay. But anyways, I was looking at the diameter, the tilt function, and also the range, the heat range at which it works. So again, this one, it says in the owner's manual, it says between 50 to 300 degrees Celsius. Other brands I saw was only was actually a little bit lower than that. It was like maybe 250 degrees Celsius or so. So anyways, and you saw when I set this thing on high, it was, at the base anyways, it was what was it again? It was 260 something Celsius. What I didn't show you guys, I forgot to show you guys, was instead of the base down here, I'm gonna go up the I-beam, right? Go up the web of the I-beam there, and you see that it's actually a little cooler. So this one shows Fahrenheit is 280 something. Down at the base is 3. Down at the base is 3. I want to show an angle where you can see the light. Okay, 3 at the base is 3. Was at 340 Fahrenheit, and up at the I-beam it's at 3. No, 3. Just under 300. 290 something. All right, so let's look in Celsius. So the base is 170 something, right? So it's still dropping. Right. Still dropping. 175. Let's look at the I-beam section. 240 something. So leaving it on low definitely. I think it works a lot better, and it just it's just easier on the tag motor, so it doesn't overheat that motor, because the tag motors, when they get overheated, they just get destroyed and it just becomes worthless. So yeah, that's it. So thanks for watching.